All right, so I need to find f triple prime. This is the third derivative, and I hope it's obvious that if I'm asking for the third derivative, I have to do the first and the second derivative. So you're just going to do the derivative 3 times. It's really simple. However, you have to rewrite the thing before you can even take the derivative, and this is where people have an issue. This is fine. This is fine. This is not fine. This is not fine. Everything else is okay, although the last term I can write. So 2x third, mistake people make when they're rewriting is they take this derivative. Like here, they'll put 6x squared. This is wrong. You can't take the derivative while you are rewriting the terms. Everybody that doesn't need to be rewritten, you leave the same. Now, this dude I have to rewrite. The root, this is a square root, so it's a 2 on the bottom and the 3 goes on the top. And again, if you rewrite that power incorrectly, all your derivatives will be wrong. This I have to move to the top. I can't leave it like that. I can't just do, oh, 1 over 2x. You have to move it up as x to the minus 2. Remember, when you move it from the bottom to the top, the power switches sign. Sine x, I don't have to mess with. And I'm pretty sure the square root of 9 is 3, so I may as well write 3 there. This is my rewrite. Again, this doesn't change. This doesn't change. Don't take derivatives here. I haven't taken the derivative yet. This is not f prime, this is f. I see you do this on your test, it's wrong, okay? You cannot do that. Now I'm gonna take the derivative because everybody's rewritten. So I'm gonna do f prime first. And again, this is all power rule. You got 6x squared. The derivative of 7x, you drop off the x. Here I multiply by the power, so if you wanna do it on the side. Multiply 2 by 3 over 2. Those just cross out. You get a 3. Now I have to subtract 1. So 3 halves take away 1. 1 is 2 over 2. So that leaves me with a half. You know, do this on the side. I expect to see this work on the side. I mean, you know, you can't do all this in your head. You shouldn't. Multiply here. This is negative 1 times negative 2, which gives me a positive 2. Subtract 1 off the power. Be careful. Don't mess up there, right? I see people subtract this wrong all the time. The derivative of sine is cosine. And the derivative of 3, it's a constant. It's 0, it goes away. Now I'm going to do f double prime. This is the second derivative. So you just keep going. Derivative of 6x squared is 12x. 7 is a constant. Goodbye. Multiply 3 by a half. Well, it's 3 over 2. X. Now I have to do a half, take away 1. So it's 1 half minus 2 over 2. So you get negative 1 half. You know, don't be shy about doing this. You don't have to do it in your head. I'm sure a lot of you can. So you get negative 6, right? 2 times negative 3. The sign's going to keep switching here. You have a negative power. So it's going to constantly go back and forth between plus and minus. So just be careful with the signs. The derivative of cosine is negative sine. So I'm going to get a sign switch here too. Again, this derivative is going to keep going back and forth between sine and cosine. But every other one it's going to switch because of the cosine one. Now I'm up to the third. Yay, finally. I mean, this is what the question originally asked you for. Find f triple prime. I had to rewrite first derivative, second derivative. Now I'm finally up to the one I wanted. Third derivative. Derivative of 12x is 12. If I were to do it again, this would be gone. Multiply again. Now, negative 1 half. So this is going to be positive times a negative. So it's negative. 1 times 3 is 3 on top. 2 times 2 is 4 on the bottom. Right? You multiply the tops, you multiply the bottoms. Subtract 1 off of that. So again, negative 1 over 2, take away 2 over 2. It's negative 3 over 2. Again, multiply by the power. Minus times a minus is a plus. 6 times 4 is 24. Subtract again. Now, this would be a pretty big number if you do this a 4th time, which I won't have you do. And I will avoid this since I'm not letting you use calculators. I don't want you to have to sit there and do 24 times 5 by hand. All right. And then the derivative of sine is cosine. So it's not going to switch. It's going to stay negative. So there it is in all its glory. The third derivative. Again, rewrite first, second, then third. This is how it'll be asked on an exam. It's just going to say, find the third derivative. It's understood you have to find the first and second derivatives before you can find the third. All right, so I want the derivative of a product. So I have to use the product rule. So again, I think of this guy as my first, and I think of this guy as my second, right? There's a big dot between them. That's your product. So I'm going to do first. So I want the derivative. So I'm going to do the first times the derivative of the second plus the second times the derivative of the first. I'm writing it out all careful, right? Remember, the prime means derivative. I could have written this down. I could have written ddx of ln x. It means take the derivative of the thing next to it. But either way, it's fine. Now I'm going to just take the derivative. So first, derivative second. The derivative of ln x is 1 over x, if you remember, it's in your rule list, plus the second guy times the derivative of the first guy. Easy power rule. Now, I can neaten this up a little bit. I would greatly prefer you don't leave this like this. I have x to the 6 on top, and I have an x to the 1 on the bottom. So I can use my exponent rules and get x to the 5. And I'd be more comfortable putting this in the front, and I'll tell you why. A lot of people see this x here in the ln, in the natural log, and they will multiply this x with that x. And that's a bad mistake. So to avoid that temptation, I will write it in the front like that. And you might be saying to yourself or to me, but you have x to the 5 here, you have x to the 5 here, you can factor out into the front the greatest common factor. My question to you would be, why the hell would you do this? I mean, it's not necessary. Can you simplify it a little? Sure. Does it benefit you in any way, shape, or form? No. Now, a dumbass thing to do here would be to say, oh, I have x to the 5 plus 6x to the 5. I can add them together and make 7x to the 5. That is absolutely ridiculous. I mean, you know, if you had like 3 plus 6x, would you tell me this is 9x? I mean, this thing is attached to something else, so you can't just add those parts together. So whatever you do, don't do anything silly. It's a very easy problem. First, derivative second, plus second, derivative first. Product rule is very easy to do, and you don't have to do much at the end. I had to do a little simplifying here, and I just moved him to the front. But other than that, don't mess with it too much. All right, so taking the derivative of a fraction. It is not as simple as take the derivative of the top, take the derivative of the bottom. You have to use a quotient rule, which says you take the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. All right, so I'm using T for top, B for bottom. If you don't like that, tough crap, I don't care. This is how I do it, all right? There is a top and a bottom. I don't care about the math words. So I'm going to just start doing it. I'm going to take the derivative. So I'm going to take the bottom and multiply it by the derivative of the top. And this time I'm actually just going to do the derivative of the top. The derivative of x squared is 2x. The derivative of minus 5 is 0 because it's a constant. So bottom, derivative top, minus the top times the derivative of the bottom. What's the derivative of the bottom? The derivative of 3 is 0. It's a constant. The derivative of negative 2x squared is negative 4x. You can already see how nasty this is. All over the bottom squared. Now I'm going to give you a piece of advice. Never, ever, ever multiply this out. You don't need to. Now, the mistake that people will make is, this is a very tempting thing, and I want to show you what people do. Like, if I gave you something like this, and you decided, oh man, look, there's x's. I can cross them out. This is a dumbass thing to do. I mean, if you had like 3 take away 2 over 3, which is a third, right? 3 minus 2 is 1. If you decide you're going to cross these 3's out, I mean, I'm pretty sure that that's not 1/3. All right, you can't cross out like this. Even though you see the same dude here and here, do not, under any circumstances, cross these out. It doesn't work, okay, because of this. Now, I can clean this. I can simplify this. So I'm going to. And you need to also. I'm not going to times this out because there's no need to. I'm going to distribute this 2x. 2x times 3 is 6x. 2x times negative 2x squared. 2 times negative 2 is negative 4. And then I have x2 times x1, which is x3. Now, I have to be super careful here because there's a lot of shit going on. I am going to take this minus. I want to put this in the front. I'm going to move this to the front there. And when I do that, this negative and this negative will make a plus. This, I think this is much easier to multiply it out. I'd rather have this in the front of the parentheses and then distribute it. I don't want to distribute it from the back end. It looks weird. So I'm just moving it to the front. And this negative make a plus, right? You have minus. There's a -1 there. You multiply it by -4x. You get positive 4x. Now I'm going to distribute. 4x times x squared is a positive 4x cubed. You screw up your signs here. This whole thing is totally effed. And then you're going to multiply again. 4x times -5 is -20x. All over the bottom squared. So I was very careful how I multiplied it out. Look, you don't have to do exactly what I did. I think it's a lot easier, and it minimizes the chances of you making a mistake. You could have distributed the minus sign into here and then multiplied the -4x and left it there, whatever. I like this in the front. So I always move this to the front before I multiply. Now, these wipe out. I mean, you have a positive 4x3 and a negative 4x3. They go away. And these are like terms. I can combine them. I have 6x's, and I lose 20. Let's hope this is going to fit at the bottom and we can see it all. 6 take away 20 is -14. X all over. But you should multiply that out. No, you shouldn't. There's no reason to multiply it out. Why would you times that? There's no benefit to multiplying this out, right? I mean, you would get 9, take away 12x plus 4x squared. What the hell did that accomplish? Does it look nicer? I don't know, whatever. A computer program might multiply it out. I don't. So this is the quotient rule. Bottom derivative top minus top derivative bottom all over the bottom squared. Simplify when you can. If I had other crap in here, like sine and cosine and ln or e, I wouldn't be able to do what I did. There's not much that would cross out. But in my example, I was able to simplify this quite a bit. So if you can simplify it, I expect you to. And if you can't, then you don't. All right, I'm going to give you cosine over sine, which is cotangent. I want to know what the derivative of cotangent is. So first I rewrite cotangent as cosine over sine, and now I'm going to use the quotient rule, which is bottom, derivative top. Now derivative of cosine is negative sine, minus the top times the derivative of the bottom all over the bottom squared. Now here's where a lot of you are really screwing this up. You cannot write this. This does not mean the same thing as this. This means sine x, sine x. This means sine xx. This is not the same. So you cannot write this. All right? It doesn't mean the same thing. So you have to be really careful. So now I'm going to multiply these together. Look, there's a negative there. So I'm going to put the negative in the front. Sine times sine is sine squared x. My n looks a little funky there. All right? Now, same thing here. Cosine times cosine. The negative stays there. Cosine times cosine is cosine squared x. Now on the bottom, I'm going to write sine squared x. And you're thinking, oh, you can cross them out. No, you can't cross them out. But what you can do is notice that you have a negative here and a negative here. Now this is the move that most people don't like. I'm going to take that negative and I'm going to factor it out of the top. Now, why the heck am I doing that? You'll see in a minute. When I do that, I get sine squared. This negative is going away now, and I'm replacing it with a plus. And I hope you'll understand why I'm doing this in a second. And if you're not, I'll explain it. I need to replace the top with a trig identity. I don't have an identity that says negative sine squared take away cosine squared. I have an identity that says that sine squared plus cosine squared is 1. So I needed to factor out this minus sign and put it in the front. This doesn't happen when you do tangent. That's why I'm doing cotangent for you. So I keep the negative in the front, but sine squared plus cosine squared is a trig identity that is equal to 1. So I'm going to put a 1 there on the top. And on the bottom, I have sine squared. Now, what is sine squared? Sine squared is 1 over sine times 1 over sine. But 1 over sine is cosecant. So I'm going to replace him with cusk, and I'm going to replace him with cusk. That's going to give me cusk squared. So when you have 1 over sine squared, you replace this dude with cosecant squared. And don't forget the minus sign that goes in the front. So the derivative of cotangent, who's cosine over sine, is negative cosecant squared, negative cusk squared. All right, so tangent has a similar derivative, right? Remember, they're reciprocals of each other. So when I had you do tangent, you did sine over cosine. So it's very, very similar, except you don't have to deal with this negative sign. But you have to be very, very careful how you write this. You cannot write this down. This is incorrect. All right, so I don't need that anymore. So 1 over sine is cosecant, but I have 1 over sine squared. So that's cosecant squared. And then the negative goes along for the ride. So that is the derivative of cotangent.